Okay, let's give this a try. We're looking at investigating patterns, section 1, 2. If you remember on Friday, we started doing this a little bit with the vocab and looking at the samples. Here's our objectives. We're going to describe patterns using tables and variable expressions, and we're going to evaluate variable expressions. Okay, so one of your problems might look like this today, okay? So you have a row of triangles built with matches. Okay, we're going to continue the patterns. We've got shapes 1, 2, 3. We want to continue it for shapes 4 and 5, see if we can predict it, okay? Then create a table of the perimeters of the shapes. Write a variable expression for the perimeter of shape n. So what that would look like, okay, that's what shape 4 and shape 5 would look like if we continued this pattern. And this is the table we're going to need to make so that we can organize everything, okay? So we've got shape 1, the perimeter, and remember, is out around the outside. So we've got 1, 2, 3 matchsticks. Versus on this one is 1, 2, 3, 4. Not this one, we're just doing perimeter, okay? You can kind of see a pattern here. 1, 2, 3, 4, 5. Okay, it looks like we're adding one every time. So we'll verify. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. Okay, works great until we get to this part, all right? Because now we have to write a variable expression for the perimeter of shape n. Remember the book's definition of a variable expression? Remember I said I didn't like it very much, but basically it's an expression that contains a variable. Expression is a mathematical sentence, but it doesn't have an equal sign. An equation has an equal sign. An expression does not. A variable is going to be some unknown. So in this case, it's n. All right? So we have to figure out if n was like the 20th shape, or the 100th shape, or the 5,000th shape. Okay? I don't want to draw all that out. So what this is going to do for us is we're going to create a little shortcut. So to figure it out, we can't just add 1 every time. We've got to figure out a pattern from here to here. So from the shape to the perimeter. Well, from here to here, I can multiply by 2. Okay, but it's got to work for all of them. Well, is 3 times 2 equal 5? No, so it's not multiplying by 2. So let's try adding. 3 plus 2 is 5. Is 4 plus 2 6 and 5 plus 2 7? Yeah, it works for all of them. So in terms of n, we would take whatever the shape number is, okay, which in this case we're going to call it n, and we're going to add 2 to that. So whatever this is, if it's the 100th shape, we'd add 2, that would be the perimeter. If it's the 50th shape, we add 2, that's the perimeter. Okay? All right, similar problem here. I just stretched out the triangle a little bit. All right, so, and I also changed the numbers. So, it's a little more difficult, so let's see how it works. We got 4, 8, and 2 gets me 10. This would be 4, 8, 10, 12. 4, 8, 10, 12, 14. So we can see our pattern here. Looks like it's adding 2 every time, right? And we could verify that by looking at these. Okay. Now, to get from here to here, well, from 2 to 12, I think automatically multiplying by 6, okay? So let's take 3 times 6, oh, it's not 14, so it's not multiplying by just a singular number, okay? So let's try adding. So to get from 1 to 10, I'd add 9. Well, 2 plus 9 does not get me 12, all right? So it's not just adding, but we do know it's getting bigger. So if it's not just adding and not just multiplying, it's got to be a combination of multiplying and adding, okay? I suppose it could be subtracting too, but we're looking at the multiplying and the adding in some form to get us this expression. So we could try, let's just try 2n. If I double my n, let's see. 4 times 2 is 8. 8 plus 8 would get me 16. That would work here. All right, let's try that here. 3 times 2 would be 6. 6 plus 8 is 14. Oh, I think we got it. So 2 times 2 would be 4. 4 plus 8 gives me my 12. We got it. This is our expression, all right? So 2n plus 8. No matter what n is, all right, you're going to double it and add 8, and then that's going to be your perimeter. Okay, evaluating variable expressions. So when you evaluate a variable expression, you substitute numbers for the variables to find the result. So for example, suppose you make $8.50 an hour at your job. How much would you make after each number of hours? Write the variable expression first, then substitute for h. So for 3 hours, okay, the variable expression, let's do that first. So we got $8.50 times h, the number of hours that we work. So 850h is our variable expression. 850h. And we're saying, well, if h equals 3, oops, sorry about that. We're going to substitute in. So 850 times 3 is going to get us our answer. Okay? So, check my math. Is going to get us $25.50 if we work 3 hours. Same expression, 850h, but this time h is going to equal 8. Okay? So 850 times 8 is going to get us $68. Okay? And if we work a whole week, we got 850h again. But this time, h equals 40. Sorry about that, my pen's being goofy. And that's going to get us $340. Okay? And the last one. Okay, Alex makes $9 an hour. Write a variable expression for the amount he earns in h hours. Well, that's pretty similar to this one, except he's making a little bit more than we did, right? So 9h. 9h. There we go. The number of books needed to be kept is 10 more than the actual number of students. Write an expression to represent the number of books for t students. So however many students we have, we need to have 10 more than that. So t plus 10. Okay, these are both variable expressions, and that's what they asked us to do.